This is an embryology model showing the derivatives of the somites. First, let's try to identify the structures. This is the surface ectoderm. This is the neural tube. So this is a stage where the neural tube has already formed and the surface ectoderm has already fused to close the defect. And the paraxial mesoderm has been segmented. This is the paraxial mesoderm on one side, and the other side they have shown the differentiation of paraxial mesoderm into somites, and these somites are further subdivided into sclerotome, myotome and dermatome. The sclerotome migrates around the developing neural tube, giving rise to the formation of the vertebra. The entire vertebral column along with the ribs is actually derived from this sclerotome. What is the fate of the myotome then? Remember, the myotome will give rise to the axial musculature. What happens to the dermatome? Remember, we have the surface ectoderm here. The surface ectoderm gives rise to the epidermis of the skin and also its appendages, whereas the dermis of the skin is derived from this dermatome. In addition to all of this, we have a new structure which has been shown here, which is coming from the neural tube, penetrating or passing through the sclerotome and supplying the axial musculature. Now, if you observe the axial musculature, this is getting divided into a dorsal mass and a ventral mass. What exactly is this? This is your spinal nerve. This is the dorsal root ganglion, the ventral root, the trunk of the spinal nerve. Where did this come from? Remember, this comes from the neural crest cells, which is also a derivative of the neurectoderm. As we can see here, this is the ventral ramus which supplies the ventral musculature. This is the dorsal ramus which supplies the dorsal musculature,